While space is largely a vacuum, it's not entirely empty. The layers of space are defined by different physical properties and forces rather than by solid boundaries. These layers are more like different regions or fields that extend through space. Key layers and regions in space. Here are some of the ways we can define layers in space, moving outward from a planet or star. 1. Planetary and stellar layers, magnetosphere. This is the region around a planet or star where its magnetic field is the dominant force. For Earth, the magnetosphere protects us from solar wind and cosmic rays. The shape and size of the magnetosphere are highly dependent on the strength of the magnetic field and the intensity of the solar wind. Atmosphere. For planets with atmospheres, this is the gaseous envelope surrounding them. Earth's atmosphere is a great example, with distinct layers like the troposphere, stratosphere, and exosphere, each with different densities and temperatures. Gravitational field. Every object with mass has a gravitational field that extends infinitely into space. The strength of this field decreases with distance, so you can think of it as a series of layers where the gravitational pull is a specific strength. 2. Interplanetary and interstellar layers, heliosphere. This is the bubble-like region of space dominated by the sun's solar wind and magnetic field. It extends well past the orbits of the planets and acts as a shield against interstellar cosmic radiation. The boundary of the heliosphere, where the solar wind meets the interstellar medium, is called the heliopause. Interstellar medium ISM. This is the matter and radiation that exist in the space between star systems within a galaxy. It's a very low-density layer composed of gas, mostly hydrogen and helium, dust, and cosmic rays. It's not uniform. It has different regions, like nebulae, where the density is higher. 3. Galactic and extragalactic layers, galactic halo. This is the vast, spherical region surrounding a galaxy's main disk and bulge. It's mostly dark matter, but it also contains a diffuse layer of gas, isolated stars, and globular clusters. Cosmic web. On the largest scales of the universe, galaxies are not randomly distributed but are arranged in a vast network of filaments and clusters with enormous voids of mostly empty space in between. This structure can be thought of as a kind of layered, filamentary cosmic web that defines the large-scale structure of the universe. So, instead of being a stack of solid layers like in geology, the layers of space are more like overlapping fields and regions defined by the influence of gravity, magnetic fields, and the distribution of matter and energy. If this theory proves correct, we might need to completely reimagine our place in the cosmos. We could be living in a universe that's far more dynamic and interconnected than we ever imagined. A universe where the boundaries between matter, energy, and consciousness are more fluid than fixed. Of course, like any groundbreaking theory, it faces intense scrutiny from the scientific community. But isn't that how all great scientific revolutions begin? With ideas that seemed impossible at first, only to become the foundation of new understanding. As we continue to explore these possibilities, we might be standing at the threshold of the next great leap in human knowledge. A leap that could transform not just our understanding of physics, but our very conception of reality itself. The question isn't just about how the universe works anymore, it's about who we are within it, and what incredible possibilities await us in this vast cosmic dance. What makes this particularly exciting is how it bridges the gap between quantum mechanics and general relativity, something physicists have been trying to do for decades. It's like finding the missing piece of a puzzle that's been driving scientists crazy for generations. Remember, though, that this is still a theory under investigation. But isn't that the beauty of science? We're constantly pushing boundaries, questioning assumptions, and reaching for new understanding. Who knows? This could be the breakthrough that changes everything we think we know about the universe. Quantum physics theory replaces relativity's time-based limitations with spacefield dynamics. As time ceases in our ship at light speed, it continues in the ship. A space bubble is created around the ship at its fastest medium velocity. In the infinite energy concept explained in relativity theory, Einstein asserts no more propulsion equals c2 can be achieved. But if we look at this as a passive travel continuum, energy for propulsion can raise to a higher potential if engineering designs are greater or bigger. A bigger engine or warp drive. If the speed limit is based on gravity, and it is which compressed energy conservation in a zero vacuum and possible negative field vacuum that is yet to be discovered as a physical source. Space travel can exceed surpassing the energy speed limitation with a higher warp drive motor. Einstein's universe speed limit EMC is squared.